are three states of matter: liquid, solid, and gas. All three states of matter go through phase changes: condensation, evaporation, sublimation, melting, and freezing. First, we talk about freezing. Freezing is liquid going into a solid, which I have liquid right here, which is water, and then I have ice right here, which is liquid after freezing. This is a solid, this is a liquid. To make it into a solid, aka the ice, first we had to take away the thermal energy, aka the heat. Then we had to take away the pressure. Then we took away the kinetic energy, which is the motion of the particles. The particles are moving a lot faster in the liquid than they are in the solid. The liquid is more spread apart, which is the formation of the particles. They're more spread apart, but they can still take place at the container. But then the ice cube has a definite shape and the particles are closer and tighter together, but both of these particles are still moving. Liquid is moving faster than the solid. Solid is slower than liquid. Solid has the slowest particle movement. Next is melting. So if I just grab an ice cube right here, which I already have, and if I squeeze it for a while, it'll give me the liquid. The liquid, to do this, we had to add thermal energy, aka heat. We had to add the pressure. Then we had to add the kinetic energy of the particles, aka the motion. The particles spread up made it friction. The friction amplified the heat, and my hands amplifying the pressure. Ooh, geez, that went fine. And then the formation of the liquid is more spread apart, moving faster than the solid. But then the liquid can take place of is the shape of its container. For evaporation, I will be using a tea kettle, which you can see right here. It's a lovely tea kettle. If I press it, about 10 seconds in, just waiting for the liquid to add. It's adding the heat, which is also adding the pressure, which is also adding the kinetic energy of the particles. The heat is rising rapidly. The particles are moving a lot faster as gas, which is the gas particles are moving very, very lively and very fast. When the air is a gas, it's moving really fast. That's rhymes. And there's no really definite shape of a gas, but then the particles are moving insanely fast. And if you can see, which you probably can't, there's gas starting to come from the tea kettle, rising up to here, and coming along over. So that is evaporation. Condensation. Condensation is different. For example, if I grab the lid of a frying pan, and if I grab my ice that I have, and then put that here. This is also a good example of melting, because it's melting the ice. This pan right here is the one we're watching. I am adding the heat. I'm also going to be covering this up. Going to be doing that. And then later, this will get hotter, more steamy. And then the pan, if you get it right, then the pan will get a lot more moist, like condensation, like the morning dew in the grass. The pressure is being decreased. When it was inside, the pressure was being decreased. The temperature is going way down, and then the temperature is going down, and the particle motion is going down. This, yes, I am putting heat to it, but it's only to fry the ice. And then when it is done, and I will turn it off, the top of the lid, once it cools down, the top of the lid will become moist from liquid, because it went to gas to a liquid, aka the condensation. Yeah. And then, yeah. So, see, and I'll stop it now. I'll stop it now. This is boiling hot. You can see, well, you might be able to see the moisture along the lid, which is the condensation, because it is starting to cool down from just being at extreme hot temperature. Just not burning my hand. Ow. Okay, over here. And then water up. This is hot. Ooh, this is a good one. If you can see, just barely, there it is turning into the liquid into the gas, which is coming up to here. And I don't know if you can see it, there's steam coming up and then into the air. And the final two, diplimation and sublimation. Diplimation is a solid going straight to a gas, which, think of liquid nitrogen. Liquid nitrogen is a solid and ice, and once it hits the air, it goes boom right into the gas, right into a gas. The particles are moving a lot more faster than it was when it was a solid. The pressure is being completely bumped up so it's being added, a lot of it. And then, so it's going straight from a solid to a gas. The particles are now going rapid. They're going crazy. Me on candy. And then the formation of the particles, well, they're this. And then for the last one, sublimation. Gas going to a solid, which, that's hard to explain for me, and I can't find any examples in my old head, so I'm trying to explain it for you. It is a gas going straight to a solid. So the heat is being completely reduced completely. The pressure is being completely taken away, it's going to be gone. And then the particle movement is going to be getting dead real fast. So there's going to go to crazy, me on candy, to me after staying up for 24 hours. And then that is my 3 States of Matter project, and enjoy! The particles are now going rapid. They're going crazy. Me on candy. And then the formation of the particles, well, they're this. And then for the last one, sublimation. The particles are moving a lot more faster than it was when it was a solid. The pressure is being completely bumped up so it's being added, a lot of it. And then, so it's going straight from a solid to a gas. the particles are now going rapid. They're going crazy. Me on candy. And then the formation of the particles, well, they're this. And then for the last one, sublimation.